What's up, fellas? How's it going? This is Kazi from cleverprogrammer.com, and this is Codecademy Part 9. Isn't it awesome? We're like running out of fingers here to say the parts of Codecademy. That's awesome. All right. So, another day, another dollar. I'm pretty excited to be here with you guys, and we're going to get going. Last time we left off at new entries. So, that's where we're going to pick it up from. Okay? Just to get an overview of where that puts you, we're going to go to codecademy.com, and we're at 37%. Okay, so we're doing a great job. Let's keep it moving. Let's go to Python, hit continue. Let's check our course overview. Where does it say that? Course page. Right? We're still in lists and dictionaries, right? We're still in lists and dictionaries. We're almost done with it. So let's keep going. Start next lesson. Okay. Any day now. All right, let me just manually select it. Changing your mind. Here we go. Because dictionaries are mutable, they can be changed in many ways. Items can be removed from a dictionary with the del command. Del or delete, short for delete, will remove the key from the thing. A new value can be associated with the key by assigning a value to the key, like so. I've already shown you guys a little bit of that, right? So let's go back to our thing. Let's say that we had Johnny and we don't like Johnny anymore, right? Johnny is not our friend anymore. We don't want him. Sorry, Johnny. So what we're going to do is we're going to say delete phone book. We're going to pass in the key Johnny. And now if we do print phone book, you are going to see that Johnny does not exist. Right? Unable to reach server. Let's try it again. What is the problem here? Let's check it. Okay, hold on. Maybe this page has been here open for too long. Let's refresh it and come back to it. And you can use this URL to get all of this information. Okay, so we're gonna delete from phone book, and we're gonna delete Johnny, passing in the key right to the dictionary, and we're gonna check that phone book. Okay, now let's run it, and you see here we have Johnny. We print out Johnny's number on line 18. On line 20 we delete him, and then on line 22 we print the dictionary, and we don't have Johnny anymore. Okay, so delete, just delete the item from the list. Delete the sloth and the Bengal tiger items from zoo animals using delete. Simple. Let's do it. Delete zoo animals, sloth, and I don't want to type all the way, so I'm just going to copy paste it. You guys should type because it's good practice. So make sure you type everything, even if it's repetitive. And here I'm going to type in Bengal tiger. Whoops. Bengal tiger. Right? This guy that you see here in line 4. Okay? Just a recap of some terminology. This is a key. This is a value. This is a key. This is a value. So if you pass in a key unicorn, you'll get back cotton candy house. But if you delete the key unicorn, then unicorn will get deleted with its value as well. So cotton candy house will get deleted as well. Cool? Set the value associated with rockhopper penguin to anything other than Arctic exhibit. Right? So what does that mean? All right. Set the value associated with rockhopper to anything other than exhibit. Okay, so here we have, do we have that in the dictionary? Yeah, we do. Rockhopper penguin, right? So now we're going to change its value. So we can actually change values as well. So we can just do it the same way. Dict name, so the dictionary name, pass in the key, and then just set a new value. Simple as that. Okay, so I'm going to do just that. Zoo animals is my dictionary. I'm going to pass in the key called rock hopper, penguin, and then I'm going to say equal to banana exhibit. Yeah. All right. And now if we print it out, you see banana exhibit right here, and also see that sloth and Bengal tiger are gone from our list. Beautiful. Next one, backpack. Okay, so here backpack beetles.remove. So there's a remove command when we're working with lists. All right, so if I go here and I want to remove something, I can just say backpack, right, dot remove, and we can remove the dagger from it. Now if we print backpack, well, guess what's not going to be in it? Surprise, surprise. Dagger is not going to be inside of it, right? Because we removed it. And cool. So you can see in this example, Beatles has all these guys. You have Stuart here, but once you remove Stuart, you'll see that in the list, you don't have Stuart there anymore, right? Remove dagger from the list. Oh, cool. So that example that we just did is actually what we're supposed to do. So I'm just going to copy and paste it. Simple. Okay, now we have inventory and we have a key gold with the value 500. We have a key pouch with the value, which is a list. List containing 3 elements: flint, twine, and gemstone. And all those are all strings. Then we have another key backpack. All these keys are separated by commas. Okay, all key value pairs are separated by commas. You have another key backpack with a value of a list. Cool. So now let's see what they want us to do. We have done a little bit of this, okay? We did get ahead of ourselves earlier, but it helps us because now when we come to this part, we understand it better, right? Oh, the side effects of knowledge, right? The drawbacks of knowledge. The drawbacks are only that you just understand more now, right? Cool, let's keep going. Add a key to inventory called pocket. So we are going to type in inventory and we're going to add a key called pocket. All right, now we need to know what its value will be. Set the value, I'm reading step 2. Set the value of pocket to be a list consisting of the strings seashell, strangeberry, and lint. All right, so we're going to pass it. The value of the key pocket is actually going to be a list, and we're going to say seashell, strangeberry, and lint. Okay. Another way to maybe think about it is if you were creating a video game like Street Fighter and you wanted to have a character like Ken and you wanted to associate different move types with Ken or Ryu, however you say it. With Ryu, you know, he'll do the Hadouken or the Shiryuken, like, which is the punch, and Hadouken is where he goes like this. So you can do something like, you know, the dictionary is called maybe Street Fighter, right? Street Fighter, and you can have Ryu, and you can pass in a list of things like, you know, Hadouken and Shiryuken. I don't know how it's spelled. Right? So, and then in the dictionary, when you type in Ryu, you can see all of his moves. Okay? So again, their examples are weird. They're really weird examples. But if you try to relate it to something that makes more sense to you, it's gonna be a lot more amazing. Right? It's gonna make a lot more sense. These are weird examples. Okay, so then we use sort to sort the items in the list stored under the backpack key. Okay, so we have a backpack key here, right? But what we're going to do is we're going to sort all the value. So we're going to sort the value or the list of the key backpack. So how we're gonna do it is we're gonna set inventory of backpack, right? That, if I just wrote that, right, that would just equal this list here, okay? So how do you sort a list? You just write that list and you write dot sort, and it sorts that list. So in our case, we're just gonna call dot sort on inventory of backpack. Okay, then remove dagger from the list of items stored under the backpack. Great, so we're gonna go like this. We're gonna go backpack. Again, this will give you this list. And to remove dagger from this list, you just do dot remove and you do dagger, right? So I'm just gonna say, since inventory backpack is just another way of saying that list, I can call dot remove on inventory of backpack. Dot remove dagger. Add 50 to the number stored under the gold key. So what we're gonna do is we're gonna say inventory of gold. So basically we're adding gold. How I'm almost thinking of it is that we're removing the dagger or selling it, right? In a lot of video games, you'll sell the dagger and maybe you get back 50 more gold. So we're gonna increment our gold from 500 to 550. Cool. So we're gonna say inventory of gold is inventory of gold plus 50. This means that, so inventory of gold will give me back 50, right? This part will evaluate, or this part will evaluate to 500, and it'll just be 500 plus 50. So how you should think about it is the new inventory gold should be what inventory of gold was, 500 plus 50. Okay, that's how you increment something. If you said something like this, what you're saying is 500 plus 50. This statement in and of itself does nothing. The only way it does something is if you make inventory of gold now equal to 500 plus 50. But 500 plus 50 means nothing in and of itself. Okay? So when people are incrementing things, they get really confused by that. So just remember that this is how it's done. Okay, inventory of gold is equal to inventory of gold, what it was, plus 50 more. Cool, I'm not going to waste any more of your time expounding on that. Save and submit, and we have finished this course, and we got an achievement. Python lists and dictionaries. It's dangerous to go alone. Take this. So now we're on the last part of Python lists and dictionaries. Let's keep going. Oh, actually we completed it. Nice. All right, so let's go back to our course page, start lesson. Let's go back to our course page and see where we're at now. All right, so we just completed Python lists and dictionaries. That's amazing. Now we are at 38%. And lists and dictionaries are one of the very key concepts in Python. So it's a good skill to actually have and to practice it and get better at it, okay? Some people ask, well, when do you use a list versus a dictionary? You already know. And how I'm going to prove that you already know that is I'm going to ask you questions, like almost interactive, that you're going to answer in your head. And through telekinesis, I'm going to know what you're saying. Sorry, I don't have the power of telekinesis, but I do want you to still think about your answer. Okay, so let's say, okay, list versus dictionaries, all right? If I gave you lot of test scores and the student names were anonymous, okay, the students names, we don't have the names on there, but I just gave you a list of, like, I gave you a bunch of scores and I told you to use a certain data type to store them. would you use dictionary or lists? Okay, think about it. I'll give you 3 seconds and I'll answer this question. 3, 2, 1. You would use lists because it's just a bucket of information which is not tied to one another, and you just need a place to collect it and store it. Okay, that's where lists are very useful. Now, let's say we have a hospital where children are being born, and we need to associate the child's name to maybe their birth certificate, their date of birth, and whether they're male or female. And you have hundreds of child, so you need to store for each child their name and a bunch of other information for each child, and you need to do this for hundreds or thousands or millions of children. In this case, would you use a list data type or would you use a dictionary data type? Give you 3 seconds. 3, 2, 1. For this, you would use a dictionary, okay? Because the child, right, the child name might be the key, and your value might be their date of birth, their birth certificate, and whatever else, okay? In reality, the key would not be the child's name, because when you try to look up, let's say you were born and your name was John Smith or John Doe. Well, if I use the key to look up John Doe's information, I might get 1,000 results because there might be 1,000 babies named John Doe or 1,000 kids, right? So what would be better is probably some kind of serial code or whatever to use as a key that would be unique for each person. That's why sometimes we have social security, because that uniquely identifies us, and everybody has one social security. Okay, and same thing with a credit card. So that's something for you to think about for future. But for now, lists and dictionaries, I think you know when we should use them. Cool. A day at the supermarket. I get it. Before we begin. So now they're going to talk about for loops, which I alluded to a little bit earlier. A is equal to list of some sort for X and A. Do something for every. Okay, so for item in print item. So loops, again, are one of my favorite parts, right? I love loops so much because they're great. They help you a lot, and they automate things that would take humans thousands of years to do. And mistakes. So let's do it simple. For name, in names, print, name. I'm going to start getting in the habit of putting parentheses after your print. Okay, just start getting in the habit of that. Even though you are using Python 2 right now, still start treating print like a function, so then when you transition to Python 3, you're not like thrown back by it, okay? This advice was given to me by somebody who's much smarter than I am, and she told me to start teaching you guys by putting parentheses after the print so you can start getting prepared for Python 3. Okay, for name and names, print name. Again, this could be V, this could be, it's just an arbitrary variable name, right? This could be blah, 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 and as long as you're consistent here. Now what happens is when the loop runs, the first time the loop runs, this is the list names, right? So name becomes Adam, and then it goes to line 4. Loop is just something that runs over and over again till the given bucket or given thing ends. So in this case, the given thing is a list, and this list has 1, 2, 3, 4, 5 items. So can you guess how many times this loop will run? Yes, it will run 5 times. Okay, so while that's happening, this variable name is gonna be the first element the first time, then the second element, and the third element, and fourth element, and fifth element. So the first time it's gonna be Adam, and line 4 is gonna pretty much say print Adam, and you're gonna see Adam. Then name is going to be Alex, and then it's going to print Alex, so on and so forth. I think you already know this. I will hit that button, and here you see Adam, Alex, Maria, Martine, and Columbus. Great. We have a dictionary Webster with the key aardvark, which has a value, a star of a popular children's cartoon show. So this is, giving you an example. So here they have Webster, which is kind of like, they're using it as a Merriam-Webster or whatever dictionary. But you could also, you could create a website where you have movies and trailers. So for a movie, you could have the movie name, and for the trailer description as the value, you could put description, right? So that's another way you could use a dictionary. Okay, let's keep going. So use a for loop to go through the Webster dictionary and print out all the definitions. That is pretty simple. Loops work the same way for dictionaries, kind of like they work for a list. So just to give you an example here, for item in Webster, let's say print item, right? So this will actually print out the key names. But if we want to print out their values, again, remember, to get a value of a dictionary, you have to give the name of the dictionary and then the key. So if the item is giving you keys, then it's just as simple as putting in the dictionary name, passing in the key, and you get back the value, right? So let's see what they want us to do. So they just want out to print all the definitions. So we're gonna do the same thing. We're gonna do this, okay? Put your code below. Okay, and we've printed out all the definitions, done. Control flow and looping. Okay, now we're getting fancy. We're using for loops, and maybe we're using if-then statements in here as well. So here, what's happening? Let's take their code and let's read it. Reading is an important part of a developer's job. So we have a list of numbers with 4 elements or 4 numbers in here, 1, 3, 4, 7. So we go through each number. For number and numbers, so again, you should be thinking the first time the loop happens, the number is 1. The second time the loop happens, number is 3. Third time the loop happens, the number is 4. And then when the loop happens again, the number is 7. And then the for loop stops, and we're out of the for loop. Okay, everything that's indented below the for loop is part of the for loop. So whenever the for loop is running, every time the for loop runs, this block of code is running as well. Okay? Well, this block only runs if line 4 is true, but just for simplicity's sake, we can say that these are the only things that are considered when the program is thinking about what parts of the code to run. Once all the elements and once the for loop is completed, then we go to line 7, which means that no matter what happens, line 7 runs, because line 7 is not dependent on any other line. But that's the last line that will run in the thing. So you can see it says we printed 7, and obviously at the end we probably have printed 7. Okay, so it'll go through for number and numbers. If number is greater than 6, then print the number. So when we keep going through the numbers, if at any point we get a number from the list that's greater than 6, then we print it out. So in this case, you can understand that none of the numbers get printed except for 7, because every other number is less than 6. We'll run it. Okay, we're back online again. So for some reason, the internet pretty much died. So here, if I run this code, you are going to see they want us to put parentheses after print, because again, this is Python 3 that I'm using in repl.it, repl.it. And basically what I say happens, right? We run through the loop, number is greater than 6, we print it out, and here we print 7, and then the last line of code says we printed 7. All right, like step 2 above, loop through each item in the list A. Like step 3, if the number is even printed out, you can test if item is even by 2 equals 0. So that means this, okay? So if you want to check a number is divisible by 2, that means that the number is even. then we print it out. So how do we check if a number is even? Okay, let's take a number like 12. And if we use modulus, that gives us a remainder. So let's try putting in 5 into this, right? And let's print it out and see what we get. So we get back a 2 because 5 goes into 5, 5 goes into 10, we get a remainder of 2, right? And if we do 12 modulo 6, we get a remainder of 0 because 6 goes into 6 and then 6 goes into 12. So 6 goes into 12 perfectly. Therefore, 12 is divisible by 6 indeed. How we check that if 12 is divisible by 6 is we say, right? Because if 12 is divisible by 6, we should get back a 0. 12 modulo 6 should give me a 0. So here we're checking, does this give me a 0? If it does give me a 0, then that means 12 is divisible by 6. So I should get back a true, right? Likewise, if I put a 5 in here, I get a remainder of 2. This whole thing turns to a 2. 2 does not equal 0. This should give me back a false. Same way, you can check for divisibility by 2 by just replacing that by 2 there. Cool? So any number that we can put in, we can find out if it's divisible by 2 or not, which means if it's even or not. So we're going to do that here. For number in A, if number is divisible by 2, then print number. Is that what they want us to do? Print it out. That's what they want us to do. This is it. 2, 4, 6, 8, 10, 12. Isn't that cool? Okay, let's move on. Lists plus functions. So let's make this one the last one for this video, and then we'll pick it up next time in tutorial 10. Alright, so let's see what's going on here. We have a function, count small. It takes in an input numbers, so it takes in one variable. We can call it v, or we can be nice and call it numbers. For n in numbers, and I would say num in numbers or number in numbers, but they're just being cool and putting n. If the number is less than 10, then we increment the variable total by 1 and we return total. So effectively, we are trying to count the small numbers. So in here, right, for example, if we ran this algorithm, it would say that the total number of numbers that are less than 10 is going to give us back, what do you think is going to give us back? It's going to give us a 2, right? This should give us back a 2 because there are only 2 numbers that are less than 10. Everything else is greater than 10. So that's what this loop does, okay? It defines total to be 0 and then increments total by 1 every time the number is less than 10. And then at the end, it returns the total. Okay, so here we are calling the function count small on the list called lost. So you can either put in the variable lost in there or directly put in this list. But why put directly the list if we have used a variable to store it? So we use the count small function, pass in that list. So what happens is that this list gets passed to this function. This function replaces numbers with that list, and everywhere there's numbers, it changes it with that list name. Now this loop comes in and it says for 4, see, the first time the loop runs, it goes through the first element in the list. So it goes for 4 in this list. If 4 is less than 10, which it is, it increments total by 1, so total becomes 1. Then it goes for 8 in this. If 8 is less than 10, total increments by 1. So total increments by 1, we get 2. Then next time it goes if for 15 in that list. If 15 is less than 10, increment total by 1. Is this statement true? No, this statement right here is false. Okay, this evaluates to a false. So this part of the code never runs. So total stays at 2. Then the loop goes to 16. If 16 is less than 10, this evaluates to false. Therefore, line 5 never executes, and hence total never increments again. And you get the pattern. 23, the same thing will happen, and 42, the same thing will happen. So let's put all of this back. right? So effectively at the end, we'll get back 2, and line 10 will print that out. So let's hit run. And again, this is Python 3, so I gotta wrap that in parentheses, and we get back 2. Now we're gonna write our own functions. So write a function that counts how many times the string fizz appears in a list. Write a function called fizz count. Define, that's how we write a function. So every time we think a function, we type in def, which means define. Function name is count. It takes in a list x. So we should really call it list x or a list like this. Not list, because list is a reserved word, which is why it turned blue. But list underscore or list, num list. But here they want to be fancy and call it x just to confuse you guys. So we'll do that. Create a variable count to hold ongoing count. So we initialize it to 0, so then later we can keep incrementing count to keep track of everything that we've seen so far, and then return count at the end, I assume. For item in x, if x equal to the string fizz, then increment count by 1. So we can use this fancy notation, but don't do that for now. Just use this one. So this means that new count is the old count plus 1. So now it changes the definition of this count to 1. Okay? And then at the end, we return count. Okay? So, for example, fizz count should return 2. So this is a pretty cool function. Now we're starting to actually do something with all of this. Oh, did they want us to print it out? No, they said return it, right? So it should return. So when you return stuff, it doesn't actually get printed out. So you have to wrap that in a print to print it out. We get 0. That's weird. That shouldn't happen. Oh, if item is fizz, not x. So we get 2. Okay, so let's go through this loop and how it works. So we're calling our function fizz count. We're passing in the list, right? We're passing in this list fizz cat fizz. So this x turns into fizz cat fizz. We come to count. We initialize it to 0 for item in x. So x is this list. Item the first time is going to be fizz. If fizz equal fizz, which is obviously true, then increment count by 1. So count is now 1. Then it goes second item in loop for cat in that. If cat equal fizz, increment count, this part evaluates to false, right? And so line 7 never executes, and therefore count does not increment. Then we go to the loop last time because we're at the last element. So again, it's fizz. Here we got fizz. If fizz equal fizz, well, is fizz equal to fizz? Definitely. This is true. This part line 7 gets executed. Count gets incremented by 1. We see the loop has stopped, so we continue to line 8 finally. Let's give a little gap to make it easier to read. We go to line 8 and line 9. Line 9 returns the count, which is 2 at this point, so it returns 2. And we print out that, so this whole thing effectively turns to a 2, and then we print out this 2 right there. Okay? So hopefully you are seeing how this is working. And I'm going to copy this and paste it here. I'm going to comment out line 10 because they just gave an example and we don't actually have to write it. And they said start next lesson. Great job, everybody. You have just made it through Codecademy Part 9. Please like the video and please subscribe. We're very close to 100 subscribers, right? We're at 97 subscribers at this point. Please subscribe. Let's get to 100 subscribers. And I will see you in the next video. Codecademy Part 10. Okay? So get psyched. I'll see you soon.